Hey guys, so I'm trying to do this problem. Power. Implement this, which calculates x raised to the power of n. Okay. Some examples are given. 2 raised to the power 10 is 1024. Okay. X is a double. It can be a fraction as well, like this. So 2.1 raised to the power 3 is 9.261, and so on. Okay. X and power the n can be negative as well. In which case you would do 1 by x times power. Okay. So fair enough. So let's handle this negative as well. These are some constants that are given. So some very basic cases that we can think of is n, right? Uh, if it is 0, then we know return 1. If it is uh, less than 0, we have to handle it, which is this case. So 2 raised to the power minus 2 is 1 by 2 raised to the power 2, right? So let's say we had another helper function, and now what we'll do is 1 by x and minus n. Now there is one problem here. What is the problem? The problem is we say minus n, right? Where n is negative. So what if, so the problem is, let's do, what if n equals to minus 2 raised to the power minus 31, right? When you do minus n, it becomes 2 raised to the power minus 31, which cannot be held in this n. So what maybe we can do is just make a long, and so that, when you do minus n, 2 raised to the power minus 31 can be held in this. So fair enough. So we do this, and we do this, and else, oops, okay, so missed a semicolon. Else we just do our action. And let's implement this. Now here, we know that n cannot be 0, n 0 has been handled, and we know that n is positive. So basically, let's say answer is power, sorry, x. And we have to run some loops, and within that loop, we just keep on multiplying answer with x, and we hit answer. How many times this loop has to run? So let's say n equals to 2. Then we have already given 1x here. Then we need just one more x. So for n equals to 2, it runs 1 times, right? So I equals to 1, and it cannot run more than this. So I is less than n, right? So if n equals to 2, it will run from 1 to, and 2 it will break, which is fine. So this is the solution. Its time complexity we talk about is O of n. How many n is there? That many times you multiply answer with itself. Let's run code. Okay, some errors. We did not give in. Okay, so this works. Now let's submit. So we get a time limit exceeded when x equals to 1. Okay, so and n equals to this large value. So for n equals to 1, we can x equals to 1, we can consider a corner case wherein, let's say, we handle these two cases. If x equals to 1, no matter what, we return 1. And if x equals to minus 1, well, then we return, really, it depends upon whether the n is even or odd. So n percentile 2 equals to 0. In that case 1, otherwise minus 1. Okay, so let's see if it is happy with this. Okay, some error, fine. Okay, still time limit exceeded, but this time it's sort of a different case. Here, this is like the largest minimum value, and it's negative of that. So potentially we could even handle that as well, which is if n equals to, we know that for this case answer would always be 0, right? Because like 1 by something so many times would lead to 0 only. So let's see if this works. Okay, so it accepts it, but it's, if you look at it, its time complexity overall, it's not beating too many. So we did a bunch of hacks to meet the time limits, but overall, it's not really happy with the time efficiency. And our time efficiency is sort of linear. Now, can we make it better? So let's think about what we're doing. Let's say we task is raised to the power 50, then we are making it 2 times 2 raised to the power 49, which is equals to, and then 2 raised to the power 49 equals to 2 times 2 raised to the power 48. This is what we are trying to do. But can we improve upon it? Because this is running 50 times, right? So what if we do something like this? 2 raised to the power 50 is equals to 2 raised to the power 25 times 2 raised to the power 25, right? And 2 raised to the power 25, basically keep on dividing by 2, so to sort of make it logarithmic, this will be 2 raised to the power 12 times 2 raised to the power 12 is just 2 raised to the 24, and maybe, so we need, for odd cases we need another 2, right? And then if you want 2 raised to the power 12, then all you can do is you can just do 2 raised to the power 6 times 2 raised to the power 6, and then we just need to calculate then 2 raised to the power 3, then we need to calculate 2 raised to the power 1, and finally we need to calculate 2 raised to the power 0, right? And these are all pretty basic stuff, right? All these are pretty basic. So basically this becomes logarithmic. So let's try and change this approach here to make that happen. So there is a base condition, which is if n is 0, we return 1. And then basically what we're doing is we're getting half of its value. So let's call it half equals to power of x and n by 2. And this will recursively keep on going. And once you get this half, then whether this, depending upon whether this n is even or odd, uh, okay, we'll just return, let's say. So if it's even, then half times half. And if it's odd, then we need another x as well. So now this is a sort of a logarithm solution. Let's see. Let's first do run test cases. Okay, submit. Right, and now the technology is much better. So in this case, even if we like remove these edge cases that we needed to handle to meet the time complexity, and if you run this, because it's logarithmic, I feel like it would automatically sort of handle it. Let's see. Yep, it automatically handles. So that's it.